Imagine Earth billions of years ago. It was a harsh, hot place. Volcanoes erupted, spewing lava and gases. The oceans were a primordial soup of chemicals. Yet in this unlikely environment, life began. Simple molecules came together, forming the building blocks of life. These molecules eventually formed single-celled organisms, the earliest life forms. They were very basic, but they had the amazing ability to reproduce. This was a crucial step in the evolution of life on Earth. These early organisms were called prokaryotes. They lacked a nucleus and other complex structures found in later cells. They lived in the oceans, using energy from the sun or chemicals to survive. Over millions of years, these single-celled organisms evolved and diversified. This slow process of change is the foundation of evolution. One of the biggest leaps in evolution came with the development of multicellular organisms. This happened when groups of single-celled organisms began to live and work together. These early colonies of cells eventually evolved into more complex life forms. This transition from single cells to multicellular organisms was a major turning point. It paved the way for the incredible diversity of life we see today. The development of multicellular life allowed for specialization. Different cells could now perform different tasks. This led to the development of tissues, organs, and eventually complex organisms. The first multicellular organisms were simple, soft-bodied creatures. They lived in the oceans, feeding on bacteria and other organic matter. From these humble beginnings, life continued to evolve. About 540 million years ago, there was a period of rapid evolution called the Cambrian explosion. During this time, a huge variety of new life forms appeared in the oceans. One of the most important developments was the evolution of animals with backbones. These vertebrates were faster, stronger, and could grow much larger than invertebrates. The evolution of the backbone was a major milestone. It allowed for the development of a skeletal structure that could support larger and more complex bodies. This opened up new possibilities for movement, feeding, and ultimately survival. Fish, the first true vertebrates, evolved in the oceans. They spread and diversified, becoming the ancestors of all other vertebrates. Section 4. Mammals emerge, warm-blooded and ready for success. As life ventured onto land, new challenges and opportunities arose. Some vertebrates evolved into amphibians, creatures that could live both in water and on land. From amphibians came reptiles, who were better adapted to life on dry land. Reptiles gave rise to the dinosaurs, who ruled the Earth for millions of years. However, it was a group of small, furry creatures that would eventually inherit the planet mammals. Mammals evolved from a group of reptiles called therapsids. They developed several key features, including warm-bloodedness, fur or hair, and mammary glands for milk production. These adaptations allowed mammals to survive in a variety of environments. When the dinosaurs went extinct, mammals were able to diversify and fill the ecological niches they left behind. Section 5. Homo sapiens, the thinking ape, takes the stage. Among the many lineages of mammals that evolved, one group, the primates, took to the trees. Primates developed grasping hands and feet, useful for life in the branches. They also evolved forward-facing eyes, providing them with depth perception. These adaptations set the stage for the evolution of humans. Our closest living relatives, chimpanzees and bonobos, shared a common ancestor with us around 6 million years ago. From this common ancestor, a line of hominids evolved in Africa. These early humans began walking upright, freeing their hands for tool use. Over millions of years, their brains grew larger and they developed complex language and social structures. Eventually, about 300,000 years ago, Homo sapiens, our species, emerged. We are the product of billions of years of evolution, a lineage stretching back to the first single-celled organisms in the primordial soup. Understanding this journey helps us appreciate the interconnectedness of all life and our place in the grand scheme of things.